This project was trying to get a simple view and an easily understood view of what the current excitement around AI means. And we came to this because of where we are at the University of Toronto. And a few blocks down from us in the business school at the University of Toronto, there's this computer science department. And in the computer science department, a lot of the key innovations around machine learning and AI were developed. And we together, me, Ajay, and Joshua, run an organization called the Creative Destruction Lab. And what the Creative Destruction Lab does is it helps early stage science-based startups scale. And we started it in 2012. And as we started, in our first year, we had a couple of companies that were calling themselves AI companies before anyone was really thinking about AI companies, because they were driven by PhD students out of our lab, out of the computer science department, mostly Hinton's PhD students. And then the second year, there were a couple more. In 2014, there were a few more. And by 2015, there was this flood of companies calling themselves AI companies. And we realized this was something we should get our heads around. Luckily, at the same time, Ajay and I were on sabbatical. Okay, so we had some time, we could think. And we were actually on sabbatical just down the road. We were at Stanford. And we got to see both the flood of companies coming into our lab in Toronto and the excitement that was starting to percolate here in the Bay Area. And we realized that we had a bit of a lead. So we saw these companies first, and it was time to really get our heads around what this all meant. And so the insights in the book, and what we're going to talk about for the next 40 minutes or so, are explicitly based on, one, seeing all these now hundreds of science-based AI startups coming through the lab, and two, our experience of being right here in essentially the center of it all on the innovation side, the commercialization side, to figure out, well, what's really going on? Okay. So in this crowd, we need to have no shyness about that. There's a lot of hype around AI. There's some sense that artificial intelligence is going to change everything, right? We see these headlines almost every day. And we also see these other headlines with a little bit of anxiety. Wait, if the machine's intelligent, what about me? I thought that was what I did. That's what humans do. If the machines are intelligent, what's left for us? And underlying this is a lot of confusion, really, about what is artificial intelligence. Okay, so if you read the press, you have some sense that artificial intelligence is either on the happy side, something like C-3PO, which is a robot who essentially does everything that a human can do, but is friendly and nice and helpful. Or perhaps we have Skynet from the Terminator, where intelligent machines are going to take over the world. Now, you may or may not think that's crazy, but it's important to recognize the reason we're talking about AI in 2018, and we weren't talking about it in 2008 or 1998, is not because of this technology. It's because of advances in machine learning. And so when we think about what these advances are, why are we talking about AI today? It's because of prediction technology. And so we should think about the recent advances in AI as advances in prediction, better, faster, cheaper prediction. To try to get your heads around why that might matter and why that might be fundamental, it's useful to go back at technology. And remember 1995. So looking around the room, there might be like 6 of you who remember 1995. Okay, I remember 1995. It was a really exciting year in technology. So why was 1995 such an exciting year in technology? Well, it was the last vestiges of the public internet, NSFNet, were privatized. Netscape had their IPO, where they're valued at billions of dollars with zero profit. At the time, that was really crazy. And Bill Gates wrote his internet tidal wave email saying, this is the technology that we need to focus our attention on. Okay. So Microsoft, perhaps they'd missed it, perhaps it had been in the background. In 1995, he realized this was the future of computing, and the whole company started to change their direction toward AI, toward the internet. And so everything seemed to be changing. And people stopped talking about the internet as an exciting new technology, and they started talking about as a new economy. that the old rules didn't seem to apply, and it was a whole new set of rules that were going to apply. We didn't need our economics textbooks. We had to write new ones. Now, there was one set of people who said, it's not a new economy. It's the same old economy. We just need to understand that the costs of certain things have fallen. The costs of search have fallen. The costs of reproduction have fallen. The costs of communication have fallen. And once we understand which costs have fallen, we can apply the same old economics. Okay? And maybe the dominant academic economic textbook writer at the time, who's sitting in this room, your chief economist Hal Varian, was perhaps the leader in really thinking that through. And he and Carl Shapiro wrote this book, Information Rules, which laid out explicitly that idea, that the old economics still apply. You just need to think through what's changed, what's cheaper, and then we can draw on decades, if not centuries, of economic ideas to understand the consequences. Now let's jump back another technology generation to think this through a little bit more. So this is a semiconductor. This is the technology that's underlying your computer. Okay? And we talk about Moore's law, we think about, well, it's doubling the number of transistors in a semiconductor every so many months. How do we really think that through? What does your computer really do? Well, as an economist, I think of it this way. We think of it as, okay, it drops the cost in something. It used to be expensive, something, and then semiconductors came along and computers came along, and that thing became cheap. And so what does your computer really do? It actually only does one thing. Your computer does arithmetic. That's it. All your computer does is arithmetic. But once arithmetic is cheap enough, we find all sorts of opportunities for arithmetic that we might not have thought of before. This is economics 101. This is the idea that demand curves slope downward. When something is cheap, we do more of it and we buy more of it. But because arithmetic became so much cheaper, there were all sorts of crazy applications for arithmetic that most of us might not have thought of. So the first applications for machine arithmetic, for machine computing, were the same as the applications for human computing, right? So we had artillery tables, right? So we had cannons, they shot cannonballs. It's a pretty difficult arithmetic problem to figure out where those cannonballs are going to land. We used to have teams of humans whose job was computers. And you might have seen, the movie Hidden Figures. That's what they were doing. These were humans doing arithmetic to figure out classic arithmetic problems that were of first order importance to space exploration of the military. Then a handful of other human arithmetic problems started to be replaced by machine arithmetic. Accounting. Accountants used to spend their time adding. If you look at what the accounting curriculum in the 1940s and 1950s was, classic homework problem was to open the white pages of the phone book and literally add up all the phone numbers on a page. Why was that your homework? Because that's what you would spend your time doing after graduation. Your life as an accountant was spent adding. Accountants don't add anymore, right? This is just not what they do. On the positive side, there's still lots of jobs for accountants, and there's lots of accountants because it turned out the people who were best positioned to do the arithmetic were also best positioned to understand what to do when the machine did the arithmetic for them. But as arithmetic became cheaper and cheaper and cheaper, we found all sorts of new applications for arithmetic that we might not have thought of before. It turns out that when arithmetic is cheap, games are an arithmetic problem. Mail is arithmetic. Music's arithmetic. Pictures are arithmetic. And once arithmetic became cheap, we found all these new applications for arithmetic that we might not have thought of before. Your computer does arithmetic, but because it does it so cheaply, we end up finding arithmetic problems everywhere. And so that gets us to the current excitement around AI. Here's one of the foundational technologies behind it, a representation of a convolutional neural net. What should we think about here? Well, same graph. It drops the cost of something. But in this context, we think it's useful to think of it as a drop in the cost of prediction. Prediction is using information you have to fill in information you don't have. It could be about the future, but it could also be about the present or the past. It's the process of filling in missing information. And what we've seen is that as prediction gets cheaper, we're finding more and more applications for prediction, just like with arithmetic. So the first applications for machine prediction are exactly the same as the applications that we were doing prediction before we had these new tools. Loan defaults. You walk into a bank, you want to get a loan, the bank has to decide whether you're going to pay them back or not. That's a prediction problem. And increasingly we're using machine learning, we're using AI tools to make that prediction. The insurance industry loves these tools. The insurance industry is based on prediction, right? Are you going to make a claim or not? And how big is that claim going to be? That's a prediction problem. And so over time, we've seen increasing use of machine prediction replacing other older tools. Now, as prediction's gotten cheaper, we found a whole bunch of new applications for prediction, new ways to think about prediction that we might not have thought of before. Medical diagnosis is a prediction problem. What does your doctor do? They take information about your symptoms and fill in the missing information of the cause. That's prediction. If you asked a doctor 20 or 30 years ago if they were doing prediction, they might not have realized it. But now it's pretty clear that diagnosis is a prediction problem. Object classification is a prediction problem, right? Your eyes take in signals, light signals, and fill in the missing information of what that object is in some context for it. Autonomous driving is a prediction problem. There's the obvious prediction problem of, okay, predicting what those other crazy drivers are doing, but actually the key insight in the recent advances in autonomous driving is much more about, well, all we have to do is predict what a good human driver would do. Once we can predict what a good human driver would do, then we can create vehicles that drive like good human drivers. So it's a reframing of this prediction problem. And that's a key element of the art of understanding and identifying new opportunities from cheap prediction. How do we reframe old problems, whether it's medical diagnosis, object classification, or driving, as prediction problems, as processes focused on filling in missing information? Now, that's all well and good. And we've thought about, okay, well, we're going to do more prediction. But other things change in value as well. That's where the anxiety comes from, right? The anxiety is, well, if the machine's doing the prediction, what's the human going to do? And so this is the other Econ 101 concept that still applies in the context of cheap prediction. So when the price of coffee falls, we buy more coffee. That we've talked about already, demand curve slope downward. The second thing to note is when the price of coffee falls, we buy less tea. Okay. So when coffee's cheap, we're going to buy coffee instead of tea. When machine prediction is cheap, we're going to have machines do the prediction and not humans. Okay. But the important thing to remember is there are complements to prediction. So just like when coffee becomes cheap, we buy more cream and we buy more sugar. So when coffee's cheap, cream and sugar become valuable. The key question that you need to ask both yourself and your organization is, what are the core complements to prediction? What are the cream and sugar that become more valuable as prediction becomes cheap? And the way to think that through is to recognize that prediction is valuable because it's an input into decision making. That's why prediction is useful. That's why this is a transformative drop in the cost as opposed to an incremental one. And decision making is everywhere. You make big decisions. You make decisions on what job should I take, who should I marry, should I marry, when should I retire, and you make small decisions. Should I write that down? Should I scratch my face? Should I watch that bit again? These decisions are everywhere, and that, because prediction is an input into decision making, prediction ends up being foundational. The important thing to remember, though, as well, is that prediction's not decision making. It's a component of decision making. And we're trying to identify the cream and sugar, the things that become more valuable as prediction becomes cheap. We need to think through the other elements of a decision. And so in thinking through decision making, what we found it useful to do is put some structure around the components of a decision. And broadly speaking, we put prediction at the center because that's what's changed. But all sorts of other things are inputs into a final decision and an outcome. So your data is key. It's not news to most people here, right? Data is increasingly valuable because prediction's cheap and it's an input into prediction. Actions are in many ways more valuable because there's no point in making a decision if you can't do anything about it. And so being able to do something with your cheap prediction is increasingly important. Then the one of these that I want to talk about today is judgment. And judgment, broadly speaking, is knowing which predictions to make and what to do with those predictions once you have them. You can't make a decision unless you know what to do with your predictions. And I don't know if you guys have seen the movie I, Robot. Okay, some people have, some people haven't. But in this movie, there's one scene that makes it very clear what this distinction between prediction and judgment is. Okay? So Will Smith is the star of the movie, and he has a flashback scene where he's in a car accident with a 12-year-old girl. Okay? And they're drowning, and then a robot arrives, somehow miraculously, and can save one of them. And the robot apparently makes this calculation that Will Smith has a 45% chance of survival, and the girl only had an 11% chance. And therefore, the robot saves Will Smith. And Will Smith concludes that the robot made the wrong decision. 11% was more than enough. A human being would have known that. So that's all well and good, and he's assuming that the robot values his life and the girl's life the same. But in order for the robot to make a decision, it needs the prediction on survival and a statement about how much more valuable the girl's life has to be than Will Smith's life in order to choose. Right? So this decision that we've seen, all it says is Will Smith's life is worth at least a quarter of the girl's life. That valuation decision matters because at some point, even Will Smith would disagree with this, right? At some point, if her chance of survival was 1% or 0.1% or 0.01%, that decision would flip. That's judgment. That's knowing what to do with the prediction once you have one. And so judgment is the process of determining what the reward is to a particular action in a particular environment. And to understand the consequences of cheap prediction and its importance in decision making, I'm going to turn it over to Ajay to talk about tools.
Great. Okay, thanks, Avi. And thanks, Hal and your colleagues for inviting us here to talk about our book. So this triangle pyramid is the representation of the section. There's 5 sections to the book. And we start off with prediction, which goes over the bits that Avi just covered. And in essence, there are parts that you'll be very familiar with in terms of just the technical parts of prediction, also why machine prediction is, in what ways is it similar or different than our traditional prediction tools, and the economics of predictions. And so the essence of Avi's point that there are three key insights. Insight number 1 is that when prediction becomes cheap, we use more of it. Insight 2 is when prediction becomes cheap, that it lowers the value of the substitute to machine prediction, which lowers the value of human prediction. And implication number 3, that as machine prediction becomes cheap, it increases the value of complements to prediction, like input data. So data is the new oil. Why is it the new oil? It's new. We always had data, but it's now oil when before it wasn't so much oil because predictions become cheaper. So that data we had before is more valuable as a complement. And our human judgment becomes more valuable as prediction becomes cheaper because it's a complement to prediction in decision making. And actions become more valuable because we can apply our actions to higher fidelity predictions. Okay, so that's section 1. Section 2 is on decision making, which are how these components come together. So effectively what we're doing is we're taking, on the one hand, these recent advances in AI are a new technology for prediction, but we're applying them to 50 years of decision theory. So we've got a well-established theory, and we're just dropping this superpowered prediction tool inside a well-established theory to understand what are the implications for decision making. This section 3, this on tools, is perhaps the most practical bit of the book. I'm just going to describe a couple of the highlight bits. When we are building these tools, so tool is effectively every AI that we build right now is a tool, It performs a particular prediction task. And the way we think of this is we divide up, within an organization like this, there'll be a bunch of workflows. A workflow is anything that turns an input into an output. So it can be a product, would be a workflow. We can divide the workflows into tasks, and each task is predicated on one or a few decisions. And AIs work at the task level. Okay? So AIs they don't do workflows, they do tasks. And so just to give an example, a lot of you will probably have seen this. This was an interview with the CFO of Goldman Sachs. It starts off with this very dramatic opening sentence that at its height back in 2000, the U.S. cash equities trading desk at Goldman employed 600 traders, and now there are just 2 left. But then it goes on to, I think, the more important bits. It talks about them moving to more, the AIs moving to more automation, moving to more complex problems like trading currencies and credit. They emulate as closely as possible what a human trader would do. You can emulate as closely as possible to predict. Effectively, they predict what a human trader would do. But then most interestingly, down further on, they break up the IPO process into tasks. So Goldman has already mapped 146 distinct steps taken in any IPO. So what we do when we're working on these problems, we take a workflow, we divide into tasks. In this case, the Goldman Sachs IPO workflow can be broken into 146 tasks. And then we effectively just estimate what's the ROI for building an AI to do that task. And then we rank order the tasks, putting the ones with the highest ROI, the return on investment, at the top of the list, and then we work our way down. And so in terms of just when organizations show up and say, where do I even start, this is just a coarse description of how we start. And obviously there are many AI projects here, and this is old. I suspect it's at least double or probably triple by this stage. The number of AI tools here. We have companies, large companies that show up to our creative destruction lab in Toronto, and they'll say, hey, we've got 3 AI pilot projects in our company, or 4 or 5. Are we at the frontier of AI? And once we start breaking these things down, workflows into tasks, and figuring out where we can get a lift from building a prediction machine, we see that there are often hundreds, if not thousands, of opportunities to do that. And of course, you're at the front. This organization's at the frontier of that. So one of the tools that we have found very helpful for companies that are just starting to wade into applications of AI is this thing that we call the AI canvas. But effectively, it is just taking those components that Avi described and writing down the elements in English. So first of all, we're like, what is the key prediction of this task? And so you'd be surprised, people that do a task every day have to struggle at first trying to identify, well, what is the prediction that underlies this task? In other words, what we do is we look for elements of uncertainty. A prediction doesn't add any value when there's no uncertainty. So with our first sort of clue of where we go to look for, where we're going to get some action for deploying an AI is where are we operating in conditions of uncertainty? And then what is the key prediction? And then once an AI delivers that prediction, what's the human judgment that's applied to the prediction? And what's the action that we take as a function of having the prediction and the judgment and the type of outcome? And then 3 types of data. The data we use to train the AI, the data we use to run the AI, and the data we use to enhance the AI as it operates. And so, but the key point here is that there are people, senior level people, whether it's a bank or an insurance firm or manufacturing firm, drug discovery, who have never written a line of code, can sit down and start filling these things out. And within a day, a senior management team can have a dozen or a couple of dozen of these, and all of a sudden feel a level of comfort around, okay, I get the basic idea. Of course, they can't build an AI, but they can now have got a framework that they can hand to people who can build it. And their thinking largely centered around what is the core prediction of this task. So we found this thing to be just a useful way to get people started. Okay, so most of the AI tools that we build are like any other tools. We build them and we use them in the service of executing against a given strategy. So the organization has some kind of strategy, and whether it's a tool just like a word processor or a spreadsheet, and we build an AI tool, it just makes us more productive. So tools are generally there to enhance productivity, to enable us to better execute against a given strategy. But occasionally, these AI tools so fundamentally change the underlying economics of the business that they change the strategy itself. And so we want to just spend a couple minutes on AI tools that impact strategy. And when they do that, a common vernacular for this type of phenomenon is what some people refer to as disruption. Okay. So again, this is not an audience where this is any surprise, but if we were giving this talk 2 or 3 years ago, this would have been largely talk about if. It would have been, if we can achieve this in AI, then wouldn't this be interesting, or this would be possible, or if we could achieve that. Now, over the last 24, 36 months, the number of proof of concepts that we've had, whether it's in vision, or it's in natural language, or it's in motion control, I don't think anymore most of these are ifs. We know now that they are plausible, and so now it's just turning the crank and moving the predictions up to commercial grade. So this is now all a conversation about when, not if. So here's the thought experiment that we use for strategy. The basic idea is that we call it science fictioning. And the thing here, though, is that it's very constrained science fictioning, which is that the science fictioning is predicated on a single parameter that can move. And so the thought experiment is, imagine a radio knob, but instead of turning up the volume when you turn up the knob, you are turning up the prediction accuracy of your AI. Okay, so that's the only thing that you're allowed to manipulate. And so you do that, and then you just think through what are the consequences of doing that. So a useful thought experiment is to take this idea and apply it to an AI that everyone's familiar with, which is like the recommendation engine. So for example, the recommendation engine on Amazon. And so what's interesting about this is that it's a useful way to think about how this could have an effect that is nonlinear. So we go onto Amazon. Everybody here knows, shopped on Amazon and has a feeling for how this recommendation engine works. You're shopping around, it recommends you some stuff. And for Avi, Joshua, and I, it is on average about 5% accurate, meaning out of every 20 things it recommends to us, we buy one of them. And given the fact that it's pulling from a catalog of millions of possibilities, the fact that it serves us up 20 and we choose one is not too bad. And so the process, of course, is that we go on the website, we browse around, we see things we like, we put them in our basket, we pay for them. An order shows up at an Amazon fulfillment center, and some human gets that on their tablet, and the Kiva robots, dance around the fulfillment center. They bring up the stuff to the human. Human picks them out, puts them in the box, puts a label in the box, ships it to your house. It arrives in the back of a truck, and then someone knocks on your door. They ring the doorbell. They put the thing on your porch. You open the door. You bring in the box. You open the box, and then you've got your thing from Amazon. And we can sort of generalize that by saying that this is a business model of shopping then shipping. So we shop for the stuff, and then Amazon ships it. And so the thought experiment is now, imagine the recommendation engine, and every day the people in the machine learning team at Amazon are working away at turning that knob. And so maybe now it's at a 2 out of 10. And they enhance the algorithms, they collect more data, 3 out of 10. They acquire a data asset like Whole Foods. They learn more about our purchasing behavior offline, and they get up to a 4 out of 10 or a 5 out of 10. And there's some number, and it doesn't have to be a Spinal Tap level of prediction accuracy, but there's some, maybe it's a 6 out of 10, maybe it's a 7 out of 10, but there's some number where when they get to that level of prediction accuracy, somebody at Amazon says, we're good enough at predicting what they want. Why are we waiting for them to order it? Let's just ship it. And so why would they do that even when they know that they're not at a 10 out of 10 or 11 out of 10? Because let's say that they ship us a box of 10 things, and we open the door, we open the box, and we like 6 of the things, we keep them, and we put 4 of them back in the box. In the absence of them having preemptively shipped it to us, we might have only ordered 2 of those things from Amazon. And now we are taking 6 of them and preempting 4 things that we might have bought from their competitors. And the benefit of selling us that extra stuff may outweigh the cost of dealing with the extra returns. But now that they have those returns, to lower the cost of dealing with the returns, maybe they invest in a fleet of trucks that drive down our street once a week and pick up all the things from you and your neighbors that they dropped off that it turned out you didn't want. So why is this interesting? it's interesting because as you think about, that recommendation engine, we've all seen it and we've been using it, and it's been getting a little bit better, a little bit better, a little bit better over time. But it's not dramatic. It doesn't change a strategy. It's just a slightly better recommendation engine. But the thought experiment here is the nonlinearity. In other words, it gets better, 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 and we just feel it getting incrementally better, or some of us don't even feel it getting better. But when it crosses a line that doesn't mean perfect, there's a potentially step function change in the effect on the business. And all of a sudden they start shipping. So they change the model from shopping, then shipping, to shipping, then shopping. They ship to us, and then we shop on our doorstep. And so that's what we find that to be a very useful thought experiment. We go literally AI by AI by AI. We go through each AI and we say, okay, what happens as we turn the knob? And is this just a tool that incrementally enhances some part of the process? Or is this something that when the knob gets far enough along, that it will have a transformational effect on the business? And in the case of Amazon, who knows whether they'll do it, but it's not like they've never thought of it. They have this and a couple of patents on what they call anticipatory shipping, and they're piloting sort of versions of this already in narrow markets. But it's not, whether or not they do it's not the point. It is that you can imagine how this type of thinking about the process can have nonlinear effects on strategy. Okay, so from our perspective, when we see at this organization an announcement that you are moving from mobile first to AI first as a strategy, from an economics lens, our question is, well, what does that mean? Like, in other words, to what extent is this just pixie dust that everyone in the Bay talks about, being AI first, because if you sprinkle AI on something, its valuation doubles? And so our thesis is, no, there's really an underlying strategy here, and what is it? So in an outsider's perception of what does it mean at Google to have an AI first strategy, what it means to us is that at Google, you have put the knob at the very top of your strategy priorities. And so in other words, from an outsider's perspective, when someone says AI first, so first of all, the strategy here before was mobile first. So what does that even mean? What does mobile first mean? So from an economist's point of view, mobile first means not just that you're going to be good at mobile, because no company would put up their hand and say, well, we want to be mediocre at mobile. Everybody wants to be good at mobile. But what mobile first means to us is that the company is prioritizing performance on mobile even at the expense of other things. So that when there's a trade-off to be made, the trade will be made in favor of performing well on mobile. Okay, so what does it mean to be AI first when Google announced AI first? Peter Norvig answered this on Quora. And so his description was effectively, with information retrieval, anything over 80% recall and precision is pretty good. Not every suggestion has to be perfect, since the user can ignore the bad suggestions. With assistance, there is much higher barrier. You wouldn't use a service that booked the wrong reservation 20% of the time, or even 2% of the time. So an assistant needs to be much more accurate and thus more intelligent, more aware of the situation. That's what we call AI first. And what we would add on to his definition is at the expense, even if it means at the expense of other things. So even if it means at the expense of user experience in the short term, or revenues in the short term, or potentially privacy in the short term. In other words, things that help us crank the dial. What helps us crank the dial? Because we can transform our capabilities in terms of what we can do if we get our prediction accuracy high enough. So that's why we're making prediction accuracy such a priority. Other forms of trade-off. So when other CEOs heard your announcement, and then we started getting calls. Well, what does it mean that Google's going AI first, and should we be AI first too? This is another allocation of scarce resources, putting AI as a priority. And so when we saw this about moving the Google Brain team into the office right next to the CEO. A year ago, the Google Brain team of mathematicians, coders, hardware engineers sat in a small office building at the other side of the company's campus. Over the past few months, it switched buildings and now works right beside the area where the CEO and other top executives work. When this story came out in the Times, the part that we felt was missing was they never covered who got moved. Like, who became second? In other words, when AI becomes first, something has to become second. And that's what makes something a strategy, is that it means an allocation of scarce resources. In this case, it was scarce resources of space next to the CEO. And so, it's just as a strategy, when people put turning the knob at the top of their priority list, it means that they're doing that, potentially at the expense of other things. Okay, so I'll just conclude with this point here is what we have been feeling is some level of dissonance, which is on the one hand, people coming in and saying, hey, look, I get it. I see the AIs, like the recommendation engines of Amazon and other sites, and things like Siri and so on, all these different AI tools, and they're neat, and they're impressive, but they're not transformational. They're not transforming, industries. And so on the one hand, they see things that are neat but not transformational. On the other hand, this is a graph of venture capital going into AI. Then there's, the various countries, whether it's France or England or US, having policies making significant bets on AI. Google and then a series of other companies announcing they were going to be AI first. Then governments like China having a very aggressive strategy on AI with a fair amount of capital to support that and goals of being the leader in AI in some fields in 2020 and more fields by 2025, and then dominant across all fields by 2030, and now potentially accelerating that. The president of Russia making remarks like, the leader of AI will be the country that rules the world. And then a conference that Hal was at that we hosted in Toronto, where a number of people spoke, including Danny Kahneman, who's the author of the book, the popular book, Thinking Fast and Slow, that many of you may have read. He made the following remarks. So in other words, we expected him, partly because of his age and partly because of the fact that he's been thinking about human thinking for so long, that he would be a defender of all the things that make us human and distinct from machines. So we expected him to sort of be the conservative, wise view at the end of the conference. And instead, he closed our conference with the following. He said, I want to end on a story. A well-known novelist wrote me some time ago that he's planning a novel. The novel is about a love triangle between two humans and a robot. And what he wanted to know is how would the robot be different from the people? I propose three main differences. The first is obvious. The robot will be better at statistical reasoning. The second is that the robot would have much higher emotional intelligence. And so here he had earlier made reference to the fact that robots vision systems are able to detect changes in emotion from happy to sad or to jealous or to angry with a much higher accuracy level than humans. And not just visual signal, also audio signal. So with a very short amount of audio signal, able to detect changes in emotion much faster than humans. The third is that the robot would be wiser. Wisdom is breadth. Wisdom is not having too narrow a view. That is the essence of wisdom. It's broad framing. A robot will be endowed with broad framing. When it has learned enough, it will be wiser than we people because we do not have a broad frame. We are narrow thinkers, we are noisy thinkers, and it is very easy to improve upon us. I do not think that there is very much that we can do that computers will not eventually learn to do. So on the one hand, we have people saying, well, wait a minute, these AI tools are neat and they're impressive, but they're not transformational. On the other hand, we have so many people of power and influence saying, making very big bets on AI. How do we reconcile these two things? On the one hand, nothing transformative. On the other hand, such big investments and speculation. And of course, in our view, the way to reconcile this is having a thesis on time, which is if you think the knob will turn and you think that knob will take 10 years or 20 years to turn, then you'll make a set of investments today that are very different than if you think that knob will turn in 3 years or 2 years or something much shorter term. And of course, that knob will turn at different rates in different applications and with different access to different types of data. But in our view, from a strategy perspective, one of the most important starting points is having a thesis on time. So two people in the same industry may make very different bets based on their thesis on how fast the dial will turn. Okay, and so this was another recent article in the Times, and they're quoting Robert Work, former Deputy Secretary of Defense, and in this article he refers to talking about U.S. Versus China, and he refers to this. He says this is a Sputnik moment, and this really speaks to the point about people's thesis on time. I don't think there's any company in this country and maybe in the world that has treated this technology with such a level of urgency as Google has. In other words, you were early out of the gates. As Avi was saying at the beginning of the talk, some of the foundational innovations in this field of machine learning came out of our backyard in the University of Toronto. But this is the organization that capitalized on it first. And so I think and we think that there are organizations now across industries who are just starting to come to the realization that you came to 3 or 4 years ago, and starting to make bets in this domain. And they're realizing that this is their Sputnik moment. That in other words, these don't come around. If you are a manager or a leader in some part of your organization, these don't come around once a quarter, once a year, even once every few years. This is the type of thing that comes around once in a generation. And so from an individual's perspective, the people are they're betting their careers on, some fraction of people betting their careers on what this is going to do, and same with some companies. And one of the reasons this is a privilege for Avi and I to come and talk about our book here is that some are also doing it in our view. They're so far ahead that they are making decisions that have a humanity level impact, and there's no company more so than this one. So it's a pleasure for us to be here. That's it. Thanks.
Hi, so a very interesting talk. It occurred to me that one thing that might be missing from the picture that you described is that there's a back reaction from society that occurs when you deploy some of these AI machine learning technologies. And I'm thinking in particular, one thing you mentioned that if Google, for instance, is putting AI, turning up this knob on AI at the top of their priority list, does that mean that they are putting things like data privacy second? And I don't think anyone at this company would agree that we would sacrifice user data privacy at the expense of promoting AI. And another example is, for instance, with the recent Facebook developments with respect to Cambridge Analytica. I mean, they've turned up their AI knob so that users are spending as much time as possible on that platform, even if it's in a kind of echo chamber. And what they've seen is that there's a back reaction because of its possible political effects on the outcomes of elections. That users aren't happy with that, and in that case they might have to turn that knob back down, or at least point it in a completely different direction from the way that they're going. So I wonder if you had any comment on that angle.
So privacy is tricky for a whole bunch of reasons. And the way to think about privacy strategy, as I think we'd like to think about it, is it's also a trade-off, but in the sense that you have to have, both as a nation and a company, enough freedom to use user data so that you can do something with it and train your AIs, but enough restrictions so that your customers trust you. And that latter point is of first order importance. So if any company is seen to be abusing their users and their users' privacy, that is almost surely going to be a bad strategy and not going to improve. And they're not going to get any data, and so that's actually going to backfire on their AI point. So I think to sort of reinforce your point, it's exactly as you say, which you have to be respectful enough. You have to be respectful of user privacy, and you have to respect your users, or else they won't let you be AI first because you won't get the data to do it.
I wanted to push back on the. It seemed almost like the Amazon recommendation algorithm was being discounted a little bit there, because I've actually discovered some great books through that, as well as on YouTube. The recommendation for videos based on, oftentimes it's talks that I'm watching on YouTube. It'll recommend someone who I've never heard of, who I actually, later become really interested in and learn a lot from. So I'm really interested in this question of how those algorithms can get even better at showing people things that they that they didn't know existed. And sometimes I think with both Amazon and YouTube, I'm not sure exactly how it works, but I'm sure it's optimizing for some sort of proxy, like whether they're buying or whether they're clicking or watching. But I think with things like books and videos where they're kind of complex products, there's an opportunity to get feedback from the user, like a qualitative sort of feedback, like what I liked about this book were these types of things, and have that be a function in the algorithm to better inform the algorithm rather than just some proxy. My question, I guess, is do you know of any work being done sort of like that? I guess it would probably be more in the domain of a university or something than maybe in the private sector. But I guess, you know, the idea of sort of using a qualitative feedback mechanism to better inform the AI.
So there were two questions there. I'm going to actually answer your first question,
Okay, cool.
Which is, what do we mean by the current recommendation system not being transformative? So I think that's sort of underlying the point. Sure. What we mean by that is Amazon's business model is the same business model in many ways as the Sears catalog was 100 years ago. And so how did the Sears catalog work? Well, you got a catalog in the mail, and you looked through it, and you told Sears what you wanted to buy, and then they sent that recommendation to their warehouse, that request to their warehouse, and they shipped it to you. And as Sears improved the development of their catalogs, they started to figure out things like, oh, different kinds of customers want different things in their catalog. And so in some sense, their recommendations got better. And Amazon's recommendations are, don't get me wrong, way better than the Sears catalogs were. But at the end of the day, it's the same business model, just done better. A lot better, but done better. Where it becomes transformational is when those recommendations get so good that they no longer have to have that business model, and they can have a different business model. That's what we meant by that.
Mm-hmm. Probably a prediction that machines cannot do yet. I'd like to ask humans. From where you see the world, do you have a short list of areas where this transformative threshold will be crossed across, like beyond Silicon Valley?
So my view is that just as a thematic change, many more things will be personalized. So in other words, we do so much delivery of goods and services based on averages. So the one that everybody's familiar with is medical services. In other words, if given your age and your some very basic characteristics about you, you get treated. Now, you and I would probably get the same treatment for like we had some kind of ailment because we're both males of roughly the same age. And so many things will, in other words, are the fidelity of the predictions, in our view, will enhance to lead to personalization of, so when we talk about shopping, that's just another form of personalization of so many things that as a thematic change, we'll move from mass to personalization, which people have been talking about for a long time, as personalization will just become a thing. But now we're starting to actually see it, see it in action.
So I had a question about the judgment aspect in the model that you guys were mentioning, and it's kind of a two-part question. So the first one was with the improvements in the kind of lowering cost of prediction, will judgments become more polarized? And what I mean by that is, if as the model turns up and the AI becomes smarter and providing more accurate judgment, I think human judgment will kind of be pushed into a corner of like yes or no, right? Because for example, like the AI might come up with a prediction like 96 or 97% says you should choose option A over option B, and so the human kind of judgment aspect for that is, well, if it's only I have a 3% kind of gap, like I'm gonna go with A, so. That was the other thing. And the second thing was, if someone were to reject the kind of highly favored option out of the list and go with option B, wouldn't their judgment be more scrutinized and maybe even held more responsible since they deferred human judgment over AI?
So we think about judgment. It can be before or after you get the prediction. But here's where it gets really complicated, whether within a legal system or not, which is that you actually have to say explicitly how much you value different things. So in a car accident context, the machine, you have to pre-specify what you think a life is worth relative to other types of damage and other lives. And that opens up, in the healthcare context, we have all sorts of similar things. How much are you willing, once you have a good prediction on survival under different treatments, for example, you need to explicitly say, this is the threshold where it's worth it to save this person. And so that becomes just a first order issue because you've specified it. It can be audited. And that can be a legal challenge and a liability challenge and something that you just need to, it's a really, you cannot use the prediction without actually just explicitly saying what you value, and that opens up risk.
Let me just add to that one, which is, so first of all, you mentioned AI judgment and human judgment. In our view of the world, AIs have no judgment. AIs never have judgment. All they do is prediction. Humans do judgment, AIs don't. Now that doesn't mean that sometimes AIs can't look like they're doing judgment, because if they get enough examples of our judgment, they can learn to predict the judgment. Okay? But they don't have judgment. They are simply making predictions. So that's the first bit. So then what you said, and this is a thing that I think is really a first order issue for us to get our heads around, is you said, well, as they're doing more and more of this, is this, I think you used the word like pushes into a corner where their AIs are sort of, they're doing 98% of the work. They're doing all these predictions, and then they're just tossing them over for us to make the final judgment, and we're doing less, sort of less and less stuff. And I think that I also end up often thinking, like sort of having a thought like that in my head, and that's because I think what we're really good at as humans is we're good at extrapolating, kind of doing this knob exercise and saying, okay, if that prediction gets better and better and better, then our bit gets smaller and smaller, and the AIs do more work. And we're doing less. I think what we're very poor at, what humans are very poor at, is imagining what other things we will now apply judgment to because we have these low-cost, high-fidelity predictions that we've never had before. So the thought experiment that I offer the room is imagine, I just saw Henry Winkler being interviewed on Stephen Colbert, so he's on my mind. So imagine walking up to the cast of Happy Days and saying, imagine having a handheld device that's got super good, super fast arithmetic. Like, what would you do with it? And chances are, like in that era, people are not going to imagine any of the stuff that we're currently doing. And so I think our barrier is just imagining all the things that we're going to do and that we will apply our judgment to, because now we get to apply that judgment to much higher fidelity, cheaper predictions than we currently have. So an example to think about is, imagine accountants. Accountants used to effectively have two tasks. One is the one Avi described, which is where they would add up a bunch of numbers. So they would type them in and add them. And then the second one was after they added it up, they ask questions of their data. They say, well, what would happen if interest rates went up by 1%? Or let's say they're calculating net present value of some investment. They'll say, what would happen if our sales were 3% higher in the fourth quarter? And then they would type it all back in again with the variable changed and come up with a new answer. So they had two parts to their job. One was the typing, adding part, and the other was the asking questions of their data. Now, spreadsheets roll into town. And if Avi was a faster typer adder than me, that was a valued skill he had, that when spreadsheets arrived, now he and I are the same. Now there's a much higher return to the accountant who's good at asking questions, because the adding and typing part is super fast and cheap. And so the person who asks good questions of their data, there's a higher return to that part of the skill set. And so here, our thesis is that there'll be in higher returns to judgment, because when people say, oh, you guys do you think machines are so great? That they're going to be all these wonderful things. Do you think machines are going to be so spectacular? The answer is not really. It's just that we think that humans are not quite as great as we think we are. We're very poor predictors, and the machines are going to just become much better predictors than we are.
Thank you.